Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this word problem using the concepts of derivatives. So as per the problem, the volume of a square-based rectangular cardboard box needs to be 1000 centimeter cube. Determine the dimensions that require the minimum amount of material to manufacture all 6 faces. Assume that there will be no waste material and the machinery available cannot fabricate materials smaller than 2 centimeter in length. So in this problem, we are given the volume of a square-based rectangular box. So the first step is to draw a box because that will help us understand the problem visually. So we can draw a box like this. So this is a square-based box. So since the base of this box is a square, so it will have the dimensions that are equal to each other. So x, x, and let's assume the height of this box is y. Now we are given that the volume needs to be 1000 centimeter cube. And for a square-based prism, the formula for volume is area of base times height. And in this case, the area of base will be x times x, which is x squared, times the height, which is y. Now we are given that the volume should be 1000 centimeter cube, so we can sub in V as 1000. So this is the equation for the volume of this box. Now we have to find the dimensions that will require the minimum amount of material to manufacture all 6 faces. So the next step is to find the expression for the surface area of this box because the material is required to construct the 6 faces of this box. So for that, we'll have to calculate the area of each of the 6 faces and then add those areas. The area of the base, which is a square, will be x squared, and there is another square at the top whose area is also x squared. Now the other 4 faces are rectangles and area of each of those rectangles will be xy. So this is the equation for the surface area of this box. Now we can combine the like terms. So we get 2x squared plus 4xy. Now in this equation, there are 2 variables x and y. So we have to do the substitution from the volume equation and we can isolate y from the volume equation. We do not want to do the substitution for x because in the volume equation, the x term is x squared, but in the area equation, there are 2 x terms, x squared and x. So it will be easier to do the substitution for y. So from the volume equation, so we should divide both sides by x squared to isolate y. So we get y equals 1000 over x squared. Now we can do the substitution in this area equation. So we get 2x squared plus 4x times 1000 over square. Now we can simplify this expression. So area equals 2x squared plus 4000 x over x squared, because 4 times 1000 is equal to 4000. And now we can cancel out one of the x's in the fraction. So 2x squared plus 4000 over x. So this is the equation for the surface area of this box in terms of x. Now we can write the domain for this area equation. So we are given that the machinery cannot fabricate material smaller than 2 centimeters. That means the lower limit for x is 2. So x should be greater than or equal to 2. Now in this case there is no upper limit for x, because as y decreases in value, x will keep on increasing in value. So there is no maximum value for x, because if we isolate x from the volume equation, so the volume equation we got is 1000 equals x squared y, and if we isolate x in this equation, we divide both sides by y, so we get 1000 over y equals x squared. So as the value of y keeps on decreasing, the value of x will keep on increasing. So now we have to find the derivative of this area equation. Now in this case we have to find the derivative because we have to find the x value that will minimize the amount of material required. So that means we are looking for the x values at which the graph forms the valleys, because at the valleys the tangent is horizontal. Now in order to find the derivative of this area function, we should move the x in the denominator to the numerator, because that will make it easy to find the derivative of this area equation. So we get 4000 and then x exponent -1. Now we can excuse me. Now we can find the derivative of this area function. So prime of a. So in the first term, so 2 is the coefficient. So we get 2, and the derivative of x square is 2x. Plus 4000. Now for x exponent -1, we'll have to use the power rule. So the -1 comes to the front and we subtract 1 from the exponent. Now we can continue simplifying this expression. So we know that we are finding the x values at which the tangent is horizontal. So we can sub in a prime as 0. So we get 0 equals 2 times 2 is 4, and then minus 4000, and then x exponent -2. Now in order to solve this equation, we should move x exponent -2 to the denominator, and that will make the exponent positive. Now we have to isolate x, sorry, it's 4x, not 4x squared. Now we have to move this 4000 over x squared to the left side, so that will make it positive. So 4000 over x squared equals 4x, and we can cross multiply the x squared, so we get 4000 equals 4x cubed, and now we can divide both sides by 4. So we get 1000 equals x cubed, and now we can apply cube root to both sides. So we get x equals n. So this is the x value at which the tangent is horizontal to the area function. Now since we are given that x can be greater than or equal to 2, so here we have to test for the area values at two x values, at x equals 2 and x equals 10, because x equals 2 is the lower limit for the x value. So now we can do the calculation for area. So area at 2, so we'll sub in excess 2 in this area equation. So we get 2 times 2 squared plus 4000 over 2. Now we can evaluate this expression. So 2 times 2 squared is 8 and 4000 divided by 2 is 2000. So we got A at 2 equals 2008 and the unit will be centimeters squared. Now we can calculate the area at x equals 10. So we get 2 times 10 squared plus 4000 over 10. So we get 2 times 10 squared, which is equal to 200 plus 400. So A at 10 will be equal to 600 centimeter square. Now we have to find the dimensions that will minimize the amount of material, and we got the lower area for x equals 10. So that means our final answer should be x equals 10 centimeter. Now since we have to find the dimensions, we should find the value of y as well, and we know y equals 1000 over x squared. That's the equation for y we got from the volume. So 1000 over 10 squared, which is equal to 10, and the unit will be centimeter. So the dimensions are 10 centimeter by 10 centimeter by 10 centimeter. So these dimensions will minimize the amount of material required to manufacture this box of volume 1000 centimeter cube. So these are the steps you have to keep in mind to solve a problem like this one. So it's very important that we draw a diagram for this type of problem, because that helps us visually understand what's given and what we need to find. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.